Hi Year 12, this is the first of 3 videos for the solutions to the 2022 Maths Extension 1 HSC exam paper. Before you watch these videos, I really encourage you to have a go at completing this paper, then come and have a look at the solutions. Question 1. It is given that cos 23 pi on 12 is equal to root 6 plus root 2 all over 4. Which of the following is the value of inverse cos of root 6 plus root 2 all over 4? This might seem like a really easy, silly question, because if we want to solve this equation, of course we want to take the cos over the other side, and that becomes inverse cos. So why wouldn't the answer be 23 pi on 12? And it's actually not 23 pi on 12. This is actually outside the range for inverse cos. If we have a look at the graph, it goes like this. So it goes between -1 and +1 in the domain, and between 0 and pi. And of course, 23 pi on 12 is sitting up here somewhere. So we need to get it back inside that range. Now, looking at all stations to central, here's the equivalent. It's got to be in here or in here. Currently, it's sitting in here. So the equivalent angle that is in this range is in the first quadrant. Now, this is, remember, 2 pi take away theta is equal to 23 pi on 12, and theta is going to be pi on 12. And that's actually our answer. Question 2. The graph of f of x is equal to 3 over x minus 1 plus 2 is shown. The graph of f of x is transformed to get the graph of g of x as shown. What transformation is applied? So we need to go through each of these individually. So let's start with A. What does f of the absolute value of x mean? If we put in negative values of x, we're going to strip that negative off before we put it into the function. So we're only ever going to put positive values into the function. In other words, everything from here, which is exactly the same as reflecting the positive graph over the y-axis. So we're going to get this and this. Let me just rub a little bit out there, and you can see that that's actually the answer, isn't it? Because we won't have this bit here. The answer is A. Question 3. Let p of x be a polynomial of degree 5. When p of x is divided by the polynomial q of x, the remainder is 2x plus 5. Which of the following is true about the degree of q? Now, it's easy to see that it's not A or B. The degree of q cannot be 1 because the remainder has to have a degree 1 less than the divisor. But is it C or is it D? So the way we're going to tell is see whether there is an example of where q could have a higher degree than 2. So suppose I make p of x equal to x to the power of 5 plus 3x plus 5. And I'm going to make q of x equal to x to the power of 4 plus 1. And I'm going to divide. X to the 4 into x to the 5 goes x, multiplying gives me x to the 5 plus x, subtract 0, 3x take away x is 2x plus 5. So yes, p of x can be written as x times x to the power of 4 plus 1 with a remainder 2x plus 5, and q has degree 4. So C is out, the answer is D. Question 4. The diagram shows the graph of the sum of the functions f of x and g of x. So that's here. Which of the following best represents the graphs of both f of x and g of x? So this is just a matter of elimination. So let's start with A. Now what we're looking for is the sum of these two graphs to match this. So let's have a look at these significant points. So this one here, where I'm adding these two values, I should get something up around here, and that's possible. Adding these two, it should be negative, which is correct. Adding these two here, I get a positive, which is possible, and there as well. So A is a possibility. Let's have a look at B. So again, we've got that same thing here, so that's possible, but have a look here. These intercepts, when we add those, we're going to get a positive number. So it is not going to be B. So we've eliminated 1. Okay, coming back and now looking at C. When we add these two here, we're going to get a negative value. And I think we can safely say that's not here. So C is out. And then finally D. Have a look here. We're going to definitely get a negative value there, aren't we? Which is not the case here. So D is out. And so our answer is A. Question 5. The curve is defined in parametric form by x is equal to 2 plus t, y is equal to 3 minus 2t squared, and t is between -1 and 0. Which diagram best represents this curve? Now we can see that it has the same endpoints in each case. In fact, the only difference is really going to be concavity and if there is a turning point. So the best thing to do here is to make a Cartesian equation. So I'm going to start by making t the subject. So looking at this one here, t is equal to x minus 2, and then substituting that in here. Y is equal to 3, take away 2, and then x minus 2 all squared, and let's tidy it up. X squared minus 4x plus 4 is equal to 3 minus 2x squared plus 8x minus 8. So we have got negative 2x squared plus 8x minus 5. All right, we have concave down. So it is not A and it is not C. How do we tell the difference between B and D? It depends on whether this turning point is going to be in this domain or not. So let's work out that turning point. It's going to happen at x is equal to negative b on 2a. And from here, negative b is negative 8 on 2 times negative 2, which is negative 8 on negative 4, which is 2, which lies outside of this, doesn't it? Because it only goes 1 to 2. So our answer is B. Question 6. The following diagram shows the vector u and the vectors I plus j, negative I plus j, negative I minus j, and I minus j. Which statement regarding this diagram could be true? So you have a look at these different options. We are projecting u onto each of these vectors. So let's start with A. The projection of u onto I plus j is the vector 1.1i plus 1.8j. So I'm projecting onto this line. There's the vector there. Now, interestingly, this is drawn to scale. Could that be the vector 1.1i plus 1.8j? No, it couldn't be because this is the vector I plus j. This is 45 degrees. So A is out. B, the projection of u onto this one here. So let's draw that up. There's the projection there. Could that vector be negative 0.4i plus 0.4j? Yes, it's possible that is the right answer. Let's just try C and D. The projection of u onto this one here. Now, let me just rub some of that out. What does that look like, that vector projection? I want to take the length of this, but I want it in this direction. So it's going to be that. Now, could that be 3.2i plus 3.2j? No, it could not. And then finally, the projection of u onto I minus j. And again, let's just rub that out. We're going to take that length of this vector here. So the length of that, but in this direction. Could that be 0.5i plus minus 0.5j? No, it couldn't. So the answer is B. Question 7. The diagram shows triangle ABC with points chosen on each of the sides. Side AB, 3 points are chosen. On side AC, 4 points are chosen. On side BC, 5 points are chosen. How many triangles can be formed using the chosen points as vertices? All right, now it's easy to think that you just have to choose 1 point from here, 1 point from here, and 1 point from here, but it's not entirely correct because we could choose 2 points from here and 1 from here. That still forms a triangle. You see that? Of course, the only thing we can't do is choose 3 points from one side. So say these 3 or 3 of these, etc. Now, we could set up cases. We could say, let's just choose 1 point from side AB, 1 point from side AC, and 1 point from side BC, and then look at 2 points from this side and 1 from that, etc. But it's easier to do it with the complementary event. So the number of possible ways to choose 3 points from all of those dots is 12C3. Okay? Now, some of those aren't triangles. If we choose these 3 points, that won't form a triangle. There's only one way to do that. If we choose 3 points from this side, that won't form a triangle. And there are 4C3 ways to choose 3 points from that side. And then finally, here, we choose 3 points from this side, which the number of ways to do that is 5C3, then they won't form a triangle either. And putting that into the calculator, we end up with 205, which is C. Question 8. The angle between two unit vectors A and B is theta, and the absolute value of A plus B is less than 1. Which of the following best describes the possible range of values of theta? So these are our two vectors here. What does this mean? This is the length of the addition of those two vectors. Remember, this forms a parallelogram, so that's there. And so it's asking what value of theta is going to result in this length of the addition of the vectors being less than 1. It's fairly easy to see that the angle here cannot be acute. This will end up, because remember this has got length 1 and this has got length 1. So this is going to be longer if that angle is acute. So A is out and B is out. But what about C and D? So if I put my vectors like this, for example, there's my parallelogram here, that's what I'm wanting. There, so that's 1 and that's 1, and I want this to be 1. Remember, that's 1 and that's 1. So this angle here, these are equilateral triangles. This one's going to be pi on 3, and this one will be pi on 3. And so, in order for this to be length 1 or less, we need an angle of 2 pi on 3 here or more. The answer is D. Question 9. A given function has an inverse. The derivatives of the function and its inverse exist for all real numbers x. The graphs of the function and its inverse have at least one point of intersection. Which statement is true for all points of intersection of these graphs? Now, pretty tricky question because it looks like at first glance A is correct, but that's way too easy for question 9. We just draw a normal graph, say a straight line like this, and then we draw y is equal to x, and then draw the inverse function, just somewhere like that. We can see it has one point of intersection and it lies on the line y equals x. However, suppose we have a self-inverse function like y is equal to 3 minus x. Self-inverse means when I switch my x and my y around and make y the subject, I end up exactly where I started. See? So when I draw this, y equals 3 minus x, it looks something like that, and draw my dotted line y equals x, I get exactly the same line. It has an infinite number of points of intersection and only one lies on the line y equals x. So A is out, B is definitely out, none of the points of intersection lie on the line y equals x, and we're down to C or D again. C, at no point of intersection are the tangents to the graphs parallel. Well, interestingly enough, if we look at this example again, the derivative here is -1, and I'm going to get the same with the inverse function, which means that the tangents to the graphs will be parallel. They will have the same gradient. So C is out, and the answer is D. Question 10. Which of the following could be the graph of a solution to the differential equation dy dx is equal to sine y plus 1? Now, we could invert both sides and try and solve this differential equation. We'll be there for a while. But maybe a better way to do this is through a slope field. Now I've just drawn up part of a slope field here with different values of y. Let's start by substituting in y is equal to 0. Sine 0 is 0 plus 1 is 1. So the gradient here is 1 it's at 45 degrees. Putting in pi over 2, sine pi over 2 is equal to 1, plus 1 is 2, so it's steeper. Now putting in pi, sine pi is 0, plus 1 is 1, we're back to 45 degrees. 3 pi over 2, sine of 3 pi over 2 is negative 1, plus 1 is 0. And finally, let's put this in. Sine of negative pi over 2, that's negative 1 plus 1 is 0. Now, there's lots of different solutions here, but here's the basic shape. So let's go back to our multiple choice answers and see if we can pick which one it is. Can you see that it's B? Okay, that's it for the multiple choice. Our next video will look at questions 11 and 12.